8-1 similar right triangles. Today we're going to talk about taking a right triangle that's got an altitude in it that's divided, and we're going to try to take it apart and see what it means to be similar. Okay? So theorem 8.1.1 right off the bat. The altitude to the hypotenuse of a right triangle forms two triangles that are similar to each other and to the original triangle. Okay? So what we've got here is this. We have a triangle that has a couple of triangles inside of it, and so we see we have 1, 2, and then the big one is 3. Okay, so we have 3 triangles, and so what we need to do is we need to determine which of them are similar and how we write that similarity statement. Okay, and so what I'm going to do here is this. I'm going to say triangle ABC, which is the big one, A, B, C, is similar to the two other triangles. So two similar triangles that are the smaller ones are similar to the big one. Okay, so let's see. If I go A, B, C, so I end with the 90-degree angle. Okay, the next key that I take is A is this little bottom angle when I put this 90-degree angle on the bottom. And so I have to imagine in my mind, if I take this next biggest triangle, this triangle that's labeled 2, if I am going to write that so that similar parts are in the correct order, I'm going to start with A, and I'm going to go to the other acute angle, which is going to be C in this case, and then D is my 90-degree angle. Notice, C is my 90-degree angle in my first one, D is my 90-degree angle in my second one. So when I go to do my third triangle, I know that D is going to be my 90-degree angle again in my third one, except this time it's going to be this little one, and so I'm going to go C, B, D. Okay? You kind of have to rotate them in your mind, and as you do it a couple times, you're going to see how it works. So if I go C, B, D, that's similar to A, C, D, which is similar to A, B, C. Okay? Let's try it again in this one. So we're going to write a similarity statement for these 3 triangles. I'll start. Okay? So I like to draw them all out. So if I draw this first one out, this is going to be T. I'll put my 90-degree angle on the bottom, and this is going to be R, and this is going to be S. So see how this works? T, R, S. And that's going to be similar to, and I'll draw out my second triangle, which is going to look something like this. It's going to be the next biggest one. It's going to be SPT, but I need to kind of fill in a couple things. So I know that this 90-degree angle is going to be P because I have to line them up the same way. And if I've got P as my 90-degree angle, T is going to be my angle out here. Okay? And S is going to be my other little angle up there. So TPS. And those are going to be similar to this little tiny triangle that's formed over here. And I know that this 90-degree angle here is going to be P. And S is going to be my angle out this way. And R is up here. Okay? And so kind of rotate them in your mind. We're going to go through it in class a little bit more, but you got to rotate them in your mind and kind of figure out which side is the long side, the hypotenuse, and which side which side's forming the legs. So RT, if you'll see, is the hypotenuse of the big triangle. ST is the hypotenuse of the medium triangle, and RS is the hypotenuse of that triangle. I've actually got this one slated to do on your own, okay? And so I want you to try to write these out, okay? So remember, these line up in this way. Okay, so go ahead and pause it right here. Right afterwards, I'm going to write out the answer to this one because I want you to really get this skill down because it involves a lot of stuff where you're in your mind rotating things. So I want you to get this one down. So right after you pause this, I'm going to show you how to do it. Okay? Okay, we're back. I'm going to show you how to do this one. If we draw out our 3 triangles, I've got my biggest one. I've got that similar to a medium one, and that's similar to a small one. Okay? If I look again at my 90-degree angle, in my big triangle, J is my 90-degree angle. Okay? In my medium-sized one, M is my 90-degree angle, and in my smallest one, M is my 90-degree angle. Then if I notice that the hypotenuse is what's going on here, I'm going to look at this one in this way. LK is my hypotenuse of my biggest triangle. And so this is going to be L, and this is going to be K. So if I write out the statement for this one, this is going to be J, L, K, similar to triangle. My medium-sized one. This one's going to be J, this one's going to be K. So when I write this out, I went J, L, K. So I went M, J, K on this one. Okay, similar to triangle. M is my 90-degree angle of my little one. I'm looking at this one here. You can see me tilting my head to the side because I'm trying to imagine it. So this is going to be L, and this is going to be J. So this is going to be M, L, J. Okay, and so that's how we write those out. Notice I've done the 90-degree angle first in each of the three triangles. Then I've gone up to that first point of the hypotenuse and then to the bottom point. Something we need to understand in order to do this is geometric mean. Now the geometric mean of two positive numbers is the positive square root of their product. Okay, and so the geometric mean of two numbers will be the positive square root of their product. Okay, so x squared is equal to AB, so x is equal to positive square root of AB. Okay, so in example 2, this is a pretty simple concept. If we're taking the geometric mean of 4 and 9, we're going to say 4 times 9, that is definitely not a 9, definitely a 6. Okay, 4 times 9 is equal to 36. Well, if I take the square root of 36, that's equal to plus or minus 6, so x equals 6. I'm going to do the same thing for 6 and 15. So 6 times 15 equals x squared. So that's going to be 60 and 30 would be 90 equals x squared. I'll take the square root of 90. Okay, now look, this is where it comes in where we're going to have to do like reduced radical form. And if you'll remember, we worked on reduced radical form earlier this year. So what I'm going to do is I'm going to make this into the square root of 9 times 10, which is the square root of 9 times square root of 10. So I have 3 square root 10. Okay, that's equal to x. All right, I've got 3 down here for you to do. Go ahead and do the same thing. Practice those reduced radical forms. Okay, so try to pull out something that's a perfect square. That'll help you out a lot. Okay. Let's talk about proportional side lengths. Proportional side lengths give us a way to compare the side lengths of specific triangles. You'll see I have a lot of letters here. Okay, so go ahead and write these down because this is definitely going to be something that we can use later. Proportional side lengths of these triangles give us relationships within each of these triangles. And so when I do this, I'm going to give you something that looks like this. If I put B over A, so this B over this side A here, what I'm going to say is this is equal to a certain side or set of sides from another one of these triangles. Okay, so B over A is equal to Y over H. Okay, so notice the bottom of this big triangle and the A, which is the side, so these are the two legs of the big triangle, are equal to Y and H, which are the two legs of this medium triangle. So if I'm going to look at what else this equals, it's going to be H and X of the smallest triangle. Okay? So see how that works there. Now, if I look at this next one, and I have this triangle here, what I'm looking at is I'm looking at the ratio of other pieces. Okay, so if I put C over A, now C is this whole side here, and if I put it over the leg, it's equal to B over H. So the hypotenuse of the biggest triangle over the smaller leg is equal to the hypotenuse over the smaller leg, which is equal to the hypotenuse A over the smaller leg x. Okay? In my third relationship, I have C over B, so hypotenuse over longer leg is equal to hypotenuse over longer leg, y, is equal to hypotenuse over longer leg, h. Okay, so that's how the proportional side lengths work. We have these relationships that exist when we're able to set up these triangles as proportional. Okay? A couple of corollaries go along with this. The length of the altitude to the hypotenuse of a right triangle is the geometric mean of the length of the two segments of the hypotenuse. What does that even mean? It's actually fairly simple when you look at it. Because what it means is h is the hypotenuse, or is the altitude. Okay? So this is h. That h squared is equal to the geometric mean of the length of the two segments. Okay? So that's x and y. So when we take those two and find the geometric mean of them, h squared is equal to x times y. Okay? The other relationship that exists. The length of a leg of a right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse adjacent to that leg. So if I'm going to find the length of a leg, let's say A. So this is A or B. It's the geometric mean of the length of the hypotenuse and the segment adjacent to that hypotenuse. So if I take A squared, and that's the geometric mean of the segment adjacent to it, so x, times the whole hypotenuse. The other leg is the geometric mean of the segment adjacent to that, or y, and the whole hypotenuse. Okay? The corollaries help us find the lengths of these pieces. Okay? And so those are the relationships that exist. So if we're going to find the side lengths in right triangles, and we're going to find x, y, z, we need to find a couple of different things. If I'm going to find x, I need to recognize what x is. X is the altitude. Okay? So x is the altitude. And being the altitude, it means that x squared is equal to, and if we go back to that corollary, x squared, which in this case is the same as h, is x times y, so it's the length of the two segments. So x squared is equal to 2 times 10. So x squared is equal to 2 times 10. So x squared is equal to 20. If I take the square root of both sides, and I make this into the square root, we're finding the simplest radical form. We have 2 square root 5. Okay, so that's the length of one of them. Okay, y squared, which is one of the legs, is the length of, now remember, the leg, which is what we're talking about here, y is a leg, is the adjacent segment and the whole hypotenuse, the geometric mean of those two. So if I'm looking for y, I need the whole hypotenuse, which is 12, times the adjacent piece. So y squared is equal to 120. So if I take the square root of both sides, and I break that up into, I'm going to choose 4 times 30 equals 2 square root 30. Okay? So y is equal to 2 square root 30. Okay? Guys, it's all a pattern. And so when I go to find z here, I know that z is equal to the geometric mean of the whole hypotenuse, which is 12, and the adjacent piece. So I'm going to have z squared, take the square root, and I'll go ahead and take out a 4. And that's z is equal to 2 square root 6. Okay, so that's how that works. If you know the pattern that's available in the corollaries, you can figure this out. Okay, I want you to take this next one, find u, v, and W. Okay, in this case they give us the altitude and they give us a piece. So go ahead and set that up, find that. We'll talk about it in class. All right, guys, we'll see you next time. Thanks for watching.